we will discuss about the electric displacement vector D. This is denoted by D, the capital D. And I think this electric displacement vector is not given in so many textbooks, but if you study the old textbooks, then you can find the electric displacement vector. There are other so many names of this electric displacement vector. The other names are electric displacement, electric displacement field, displacement vector, auxiliary electric field, electric flux density, electric displacement density, etc. There are so many names of this electric displacement vector. The electric displacement vector is related to dielectric materials placed in electric field. Placed in electric field. So when the dielectric is placed in the electric field, only then we have this electric displacement vector. Otherwise, it has no sense at all. Electric displacement vector arises due to displacement of bound charge in molecules / atoms of dielectric placed in electric field. It is denoted by D. Which refers to displacement. Refers to displacement. In absence of applied electric field, the displacement vector has no meaning. So this is useful only when the electric field is applied. If there is no electric field, then there is no displacement. So since the charge are displaced, so the name is given the displacement electric vector. Due to displacement of bound charge, it is named electric displacement vector. Electric displacement vector. We are having this, the capacitor this is now positive charge, this is now negative charge, this is now a dielectric. So now we have this the negative charge, this is now positive charge, this is now dielectric. Dielectric. This is now applied electric field. This is now plate P1, this is now plate P2, this is now applied electric field E. This is a dielectric. So these are the phases on which the charge is induced. So this is the induced charge. When dielectric slab is placed between charged plates of capacitor, the faces near to plates gets induced charge. Denoted by QI. So this is the QI charge. This we denote by QI. And this if we define to this electric displacement vector, then this is it is defined as charge per unit area of layers of the dielectric. So these are the layers, surface, we are having the layers. So this is now surface, this is now surface. These are nearest to these plates P1 and P2. So this surface is getting negative charge, this surface is getting the positive charge. So in this way, these surfaces are getting the negative and the positive charge. So whatever this charge lies per unit area of this layer, that is called the electric displacement vector. It is called electric displacement vector. So denoted by D. So this D is equal to Qi upon A. A the area. Now this area of this dielectric surface, that will be equal to the area of this plate P1 and P2, where A equal to area of plates P1 and P2. So now if we have this Q, this D is equal to Qi into D upon A into D. Let D is the thickness of this diameter. This is not so much. Then we will get this D is equal to sigma I upon V. Listen now you. Sigma I upon V, this is the polarization vector. Where D equal to thickness of slab. And this volume V equal to A into D. This area multiplied by this distance or this thickness, that will give you the volume of this dielectric. So this V equal to A into D. So now this, the induced this is sigma I, this is what? This so much. Qi into D. Sigma I is equal to Qi into D. This is now induced surface charge density. Induced charge. Qi into D. Where Pi equal to induced dipole moment, and this Pi upon V, this is equal to P. P is equal to the polarization vector. P equal to Pi upon B. This is now polarization vector. Polarization vector. So now we can have thus electric displacement vector is the measure of polarization vector. Polarization vector. Now we can have unit of D. Now this is your coulomb per meter square. So now dimensional formula. This is now your M0, L minus 2, T1 and A1. The electric displacement vector is proportional to applied electric field. It means this D is proportional to E. So D is proportional to E, then we have to remove this sign of proportionality. So this D is equal to epsilon naught into epsilon R into E. Where epsilon R, the dielectric constant, and you will see from here that for air epsilon R is equal to 1. So this D is equal to epsilon naught E. This is not so much. And since for dielectric epsilon R is greater than 1, so this D exists there. So in that case, this D will have this relation epsilon naught epsilon R into E. And also you can see that if E is equal to 0, then D is equal to 0. So this D is proportional to E. It means that if we have this D here on this side and electric field on this side, then we can have the straight line passing through the origin, and this D is proportional to E. So when there is the electric field, only then there is the electric displacement vector. Since this electric field is produced due to the displacement of the charges, bound charges, so this is also called the auxiliary electric field. The electric displacement vector is also called auxiliary electric field. because this is very similar to the applied electric field. So this is what that the name is given, auxiliary electric field. And you can see from here that the direction of this D is the direction of the electric displacement vector. So the electric displacement vector is always in the direction of the applied electric field. The direction of D is parallel to E. It means what? That this D is parallel to E. This is what we have mean. So now angle between D and E is equal to 0 degree. E equal to 0 degree. So they are parallel to each other. Now suppose this is now a vector, electric field vector E, then this will be also the displacement vector D. So both are in the same sense, in the same direction. Over this electric field, this is the applied electric field, this is something else different from this D, and now we are having these constants also, epsilon naught. This epsilon naught is called the absolute electric permittivity. Absolute electric permittivity. So this is what about the electric displacement vector D. So always remember that the electric displacement vector arises due to the displacement of the bound charge in the molecules of the dielectric, and this exists so long as there is the applied electric field. If the applied electric field is 0, then there is no electric displacement vector in the dielectric. So this vector always exists in the dielectric in the presence of electric field. This vector also gives you the measurement of the electrical properties of the dielectric, that how this dielectric will behave when it is placed in the electric field. So thank you very much.